for your benefit so that you're able to go back and review it. Let me share my screen. Our agenda or our plan for today is to see if you had questions from the previous lesson, which apparently you all are okay. We need to finish our discussion of descriptive statistics. We need to talk about percentiles and quartiles. I need to identify for you what is the 5-number summary, how to create and interpret a box plot, and then also talk about outliers. And I'm going to show you ultimately how to do most of those things in MINITAB. We do not do those calculations traditionally by hand anymore. We allow our statistical software, whichever program we're using, to do those things for us. So that's where we're going to begin this morning. I do have the PowerPoint pulled up. I may do some work just on my paper, if you will, but we stopped our discussion at the end of class last time at the measures of position. So just as a quick review, let me go back over here for a minute. Remember, there are 5 important characteristics of data that we want to focus on when you're trying to describe a data set. And if you'll recall, they were center, variation, distribution, outliers, and then time. And I mentioned to you that time was the one characteristic that we do not really discuss that much in this course because we're limited to a 15-week semester. But time, again, I hope it made sense to you that data is going to change over time, whether that's from day to day, week to week, month to month. Think about things like the stock market or maybe sales, any kind of sales, whether you're selling carpet, cars, furniture, whatever. Sales change even from week to week, month to month, year to year. And so data can change. And so you have to take that into consideration. We did talk about distribution. And again, I want to remind you, because we're going to come back to this in a minute, I want to remind you of the 3 distributions that we talked about. We talked about skewed to the left. Skewed to the left visually, you have very few data on the low end, but you have lots of data on the high end. Remember, your scale always runs low to high, and you have your frequency on the vertical. We had symmetric. With symmetric, most of our data is centered in the middle. You have very few high and very few low. Most everything is clumped together in the middle. Okay, so that's symmetric. And then let me see if I can scroll down and get the other one, because again, we're going to come back to these 3 sketches in a few minutes. Okay, and the third one was skewed to the right. Skewed to the right visually, we had lots of data values on the low end, but very few on the high. Again, your scale always runs low to high with the frequency. We talked about how those are not the only 3 distributions that are out there in terms of statistics. Those are the 3 primary ones that we focus on in this course. We could get really fancy, but those are the 3 primary distributions that we talk about in this course. And again, knowing whether you have a skewed distribution or a symmetric distribution is going to help you to know later on what type of analyses you can and cannot do, because there are certain things you cannot do if you have a skewed distribution. Again, by way of review, just to kind of hit the high points so that we can kind of hopefully make some connections here a little bit later. Our measures of center, I call them the M&Ms because you have the mean, which is what most people traditionally refer to as the average. You have the median, which is the middle value when the data is ranked or ordered. And then you have the mode. The mode is the one that occurs the most, and it is the only measurement that we can use with qualitative data. Of those three, I mentioned to you last class that the mean is the most important for two reasons. One, it uses all of the data values in its calculation, and two, it's actually used in other statistical formulas. Then we got into the measures of variation. Variation has to do with how much the data values differ or vary from each other or from data set to data set. We had three of those. We had range, which is very easy to calculate because it's simply the max minus the min. We had the variance, and I went into some detail there, but we talked about how variance is difficult to interpret because the units end up being squared. And so that makes it challenging for us to interpret, although it is actually one of the better measurements. The one that we use most often is standard deviation. And the formal definition of standard deviation is it is the square root of the variance. We go back and we undo the square. So of those three, and I'm not sure that I mentioned it last class, but of those three, the one that we use most often or that you'll see is standard deviation. Really for the same reasons. It uses all of the data values in its calculation, and also it's actually used in other statistical formulas. So the mean and the standard deviation are the two kind of primary characteristics that we want to talk about. And that's kind of where we stopped. So I want to pick up, and we're going to talk about measures of position. But if you'll notice, position was not one of those 5 characteristics. But we have to talk about measures of position to get to outliers. The measures of position are going to help us get to the outliers. Okay, so that's why we have to pick up that particular conversation. So the next category, which is on our PowerPoint, are percentiles and quartiles. Okay, so percentiles are a measure of position. They're used a lot, especially in education and a lot of health related fields. I know when I used to take my daughter to the pediatrician when she was young, one of the things they always looked at was kind of the relationship between her height or her length and her weight to kind of see, is she growing normally, or was she below average or perhaps above average? And so, you know, if you were the nurse in that particular practice, you might have to explain that to a parent. Now, I kind of knew how to read the graph, obviously, because I have a statistics background, but you might be asked to do that. Even in education, with test scores, especially things like the Georgia milestones or the maps, even SAT and ACT, you or your child could have a percentile rank. And again, it's important that you understand how to interpret that, because you might have to explain it to another parent. So what percentiles does is it takes the entire data set, all of the data values, and divides it into 100 equally sized groups, and each group contains 1%. For me, what I picture in my mind when I'm doing percentiles or thinking about percentiles is I kind of think about kind of like little cubby holes or mailboxes, and you would have, I'm not going to draw it perfectly, but you would have 100 little cubby holes, and you have to put the data into those cubby holes so that each one contains 1%. Okay, percent literally means per 100. Okay, so that's why each one, you would have 100 groups, and each one would contain 1%. Percentiles allow you to compare how an individual value, whether it's an individual student, an individual item, how an individual data value compares to what they call the national norm. How did you as a student on who took the SAT perform in relationship to all of the other people who took the SAT? How did your child perform in comparison to all of the other students at her school, or all of the other students in the state of Georgia, or all of the other students in the United States who took the test? Okay, so it allows you to compare how one individual data value compares to the rest of the data set or the rest of the population. The challenge that we face with percentiles is that there's different ways for calculating it. It may depend upon how the researcher does it. It depends upon the assumptions that the researcher makes about the data set. And so different, even computer programs, even MINITAB in comparison to Excel or just a handheld calculator would calculate percentiles differently. So we don't actually do that calculation in this course. Okay, again, if we were doing it in the real world, we would rely on the technology that we have available to do that for us. What is important, the most important thing that I want you to get out of this is how to interpret the data value. And this is something that a lot of students struggle with. Okay. When you look at a percentile, the percentile is the percentage of the data values below that specified rank or that specified value. Okay, and I want to go back over and give you an example. I am totally making this up off of the top of my head. Okay, I don't have the actual numbers. Let's say that Miss Ralston scored on the SAT math that I scored 980, or on the SAT total. Okay, I think that could be a total. Not anymore, but when I was in school it was. Okay, so I scored 980, and on my score report that says that I scored in the 87th percentile. Now again, I am totally making this up. Okay, but I want to show you how to interpret that value. So if Miss Ralston scored 980 on the SAT way back when and was in the 87th percentile, what does that mean? Well, what that means is that Miss Ralston let me say it differently. Sorry, get my brain going on here. Okay, 87% of all the students who took the SAT at the same time as Miss Ralston scored below 980. Basically, I scored 87% better than all of the other people who took the test. Okay, you always interpret it to the value below. So the percentile gives you the percentage of all the students or all the people or all the items who took the SAT that scored below, in this case, my score of 980. You always interpret it as below. Questions? Now, again, we're not going to actually calculate the percentiles, again, because there's different ways for doing it. What we focus on and what MINITAB will calculate for us is called the quartiles. Quartiles are a special type of percentile, and it divides the data set into quarters or into 4 equally sized groups. Okay, so it divides it into quarters, which means we have 4 equal sized groups. And if I take 100 and divide it by 4, that means each group is going to contain 25% of the data. The quartiles are useful because they are going to help us to determine whether or not we actually have outliers within our data set. And then I've given you the interpretation, but I want to show it to you in a diagram. So I want to show you a diagram of kind of what we're thinking about with the quartiles. So I'm going back over to my paper. Okay, so if we have a data set, we would take a data set and we would order it so that we have the minimum value, okay, all the way up to the maximum value. We learned in the last class that the median, which is a measure of center, that's the middle, would divide this data set 50-50. So our median, which is a measure of center, divides it so that we have 50% below the median and 50% above the median. The median, if you want to think about it in terms of a percentile, it's the middle, or where we divide 50-50. So the median is also known as percentile 50. We use the letter P for percentile. Hopefully that's kind of common sense. And then we use a subscript of 50. So we read that the 50th percentile because it divides it 50-50. Just so you can maybe kind of see those relationships. Well, I can also divide it further if I want to divide it into fourths. If I find the midpoint or the halfway point between the minimum and the median, okay, so I have a halfway point here. Okay, this would be called quartile 1. Okay, and it's such that I have 25% below it and I have 75% above it. So you might think of it as the 25-75 split, if you want to think about it that way. Quartile 1 would be 1/4, or the same as percentile 25. For quartile, we do have an abbreviation, and then it's an abbreviation that MINITAB does use. They use the letter Q for quartile, and then the subscript of 1. if I divide between the median and the maximum, find the halfway point. That's going to be called quartile 3, because then I have basically 1, 2, 3, 4 equally sized groups. We would have 75% below quartile 3 and 25% above quartile 3. Again, think about it as the 75-25 split. Quartile 3, 3/4 is 75, so that would be percentile 75. The abbreviation we use would be Q for quartile with a subscript of 3. You don't see it used very often, but I will mention that the median is technically quartile 2. So quartile 2, percentile 50, and median all represent the same point. Percentile 25 and quartile 1 represent the same point. Okay, so just be aware of that. And so again, what has happened is we've divided our data set so that between the minimum and quartile 1, there is 25% of the data. Between quartile 1 and the median, we have another 25%. Between the median and quartile 3 is a third 25%. And between quartile 3 and the maximum is the final 25%, so that each group, if you will, contains 25%. Now, again, you have to remember how to interpret this. Quartile 1, that would mean that 25% of the data fall below quartile 1, whatever that value is. And I haven't put any numbers in there yet, but 25% of the data fall below quartile 1. If you want to think about it the other way, we would have 75% above quartile 1, 25-75 split. For the median, we would say 50% of the data fall below the median, or actually even above the median. Okay, I see there's a comment in the chat, so I'm going to check it out so I don't get lost. Yes, Catrice, the amount should always total to 100%, because 100% would imply that you've used all the data. Whether you're looking at percentiles, it's got to total to 100%. If you're looking at quartiles, it would total to 100%. There's also something called deciles, where it divides it into 10. Deci, prefix deci means 10. So deciles divided into a group of 10, it would also total to 100. I'm sorry, I didn't catch that earlier. Okay, then quartile 3 would be, we would say 75% of the data fall below quartile 3. Within this diagram, we also have what's called the interquartile range. If you consider from quartile 1 all the way up to quartile 3, this is called the interquartile range. It's abbreviated IQR. And it encompasses from Q1 to the median, you have 25%. From the median to quartile 3, you have a second 25%. So the interquartile range encompasses the middle 50% of the data set. And again, looking at that interquartile range can give you a little bit of sense of how much your data is spread out. It's the relationship between Q3 and Q1. Now, MINITAB is going to calculate it for you, but the formula for calculating the interquartile range is you subtract quartile 3 minus quartile 1. Now, again, MINITAB is going to do that for you. MINITAB is going to calculate quartile 1, the median, and quartile 3. I'll also mention, but I'll formalize it for you. On this diagram, you have the 5-number summary, okay, on this diagram, which is actually a very detailed rough sketch of a box plot, okay? This diagram that I've drawn with the horizontal number line marking the minimum, quartile 1, median, quartile 3, and the maximum, with the box drawn around the interquartile range, is actually a rough sketch of a box plot. Okay, so this diagram that I've drawn for you is a box plot. But again, we're going to let MINITAB do that or draw that for us. And I'll demonstrate how to do that here in just a few minutes. But on this box plot, and I'm going to formalize this for you, you have the 5-number summary, which is often given whenever you're writing a report or providing a report to someone. You typically will provide the 5-number summary along with 2 other values. The 5-number summary is the minimum value of the data set. It is quartile 1, which remember is the same thing as percentile 25. The median, which is percentile 50 or quartile 2. You have quartile 3, which is percentile 75, and you have the maximum. That's your 5-number summary. And again, that is typically reported whenever you're doing writing a report. The 2 additional values that you'll often see provided along with the 5-number summary are the mean and the standard deviation. Again, because as I mentioned earlier, those 2 values are the most important of the measures of center and the measures of variation, because we use them in other statistical formulas, and it uses all of the data values. So along with the 5-number summary, you often report the mean and the standard deviation. I'm going to give you just a second to make sure if you're going to make a screenshot or write that down, because you're going to need to know what the 5-number summary is. You also kind of need to know these relationships, that quartile 1 is the same as percentile 25, that quartile 3, or excuse me, is percentile 25, and quartile 3 is percentile 75. So you need to know those relationships. Questions? Okay, I want to scroll back up and kind of look at this box plot again, because again, one of the reasons we talk about the quartiles and dividing our data into 4 equally sized groups is because it helps us to determine whether or not we're going to have outliers. The calculation of the outliers is one of the few calculations that you will have to do by hand. Okay, so we talked about outliers, I think, last class, maybe not. Outliers are those data values that quite honestly just don't go with the rest of the data. They don't fit. They're either really, really low or they're really, really high, and they don't seem to fit or go with the rest of the data. And there's several reasons why you could have an outlier. It might be that it's a true value for that particular data set. It might be that there was a recording error, that maybe you misheard the result. Perhaps it was illegible. You couldn't read it, and so you did the best you could. And so it might be that it was, just a misrepresentation because of either a lack of understanding or a lack of being able to read the results. It could be that it's a value that is totally inappropriate. If our data set, our research is limited to, say, just males, and we've included a female, or if our data set is for people aged 50 to 84, and we've included someone outside that age range. Okay, so sometimes there's reasons for it. Again, there are techniques for removing outliers, but we are not going to talk about those. We will leave the outliers in the data set. The box plot in MINITAB, when we create it here in just a few minutes, will show you whether or not you have outliers. Visually, the box plot shows whether or not you have outliers. But we also want to confirm that or verify that with the algebra, so to speak. You want to show it with the numbers. We don't rely just on the picture. And so this is to calculate or determine the outliers. This is one of the few hand calculations that you're going to have to do. And when I say hand calculations, I mean you're going to use a calculator. You're not literally going to calculate it by hand. Okay, but it's a formula. And I'm going to give you the formula, and then I'm going to try to show you a picture, and then we'll actually do it in a minute with some numbers. Okay, so here's what the formula says. It says an outlier is any data value less than Q1 minus 1.5 times the IQR. Or it's any data value greater than Q3 plus 1.5 times IQR. It's 1.5. It's always 1.5. Students always ask that question. And that's just a standard coefficient, but it has to do with it's called the empirical rule, and the fact that if we're 3 standard deviations away from the mean, so 1.5 and 1.5 make 3. So you don't have to worry about that. It's always going to be 1.5. So visually, here's what happens. Okay, so we have our box plot, and we're going to calculate this value. We're going to calculate Q1 minus 1.5 times the IQR. And it's like that's going to create us a fence post out here. And then what we say is anything that is outside the fence. Okay, anything that's outside the fence is an outlier. Okay, so if it's less than that, where that fence post is, it's an outlier. It doesn't seem to fit with the rest of the data. We also have that on the other end. We start at Q3 and we calculate Q3 plus 1.5 times the IQR. And then anything that's above that, or again, outside the fence, is an outlier. Questions before we actually get into MINITAB? I want to actually do this with some data and calculate our statistics, descriptive statistics. Okay, now you don't have to memorize the list of statistics that you need to calculate. It will be either in the question that's on the quiz or in the question that's on the midterm. Typically, we do pretty much all of the measures of center and all of the measures of variation along with the quartiles. So ultimately, I'm going to give you a list. I may not have them in the same order that MINITAB does, but typically we're going to calculate all of the statistics that we need. So I'm going to give you a list so you'll have them when we go over there. We want to do the mean, the median, the mode. We want the range, the variance, the standard deviation, we calculate quartile 1 is Q1, quartile 3, we do the range. Oh, I already gave you range, sorry. We do the interquartile range. We do N non-missing. We talked about this the other day to determine whether we had missing data. We do N missing and N total. But I feel like I'm missing one, so give me just a minute. 1, 2, 3, 4, 5, 6, 7, 8. I think that's it, guys. Okay, so I'm going over to the internet and I'm going to open up app.minitab.com. Again, you should all have access now. Okay, I didn't have to go through and log in again because I had told it to remember me because I'm on my personal device. I need to pull in the data set. I'm going to use the Titanic data set again that we used in the last class. So I've got to go out and get it. Okay, so here are my data sets. I want the Titanic. Remember, it's in an Excel or .csv format, which requires that I copy and paste. So again, I'm going to copy. Well, I have to tell it to copy. Copy. And then paste. Jeannie, I see you have your hand raised. Do you have a question?
This is probably a dumb question, but it's outliers kind of confuse me. It's like, it seems like you're calculating the data set, like those outliers would be the minimum and the maximum, and they would sort of, would they not skew those numbers? Do you know what I mean? Like it seems like calculating based on the outliers and then you're determining outliers. How does that work?
Well, I think it'll make more sense for you, Jeannie, when we put the numbers in there, because I was just drawing it kind of where it looked like I had the same amount in each one of those regions. to
Right.
emphasize. So I think when we put numbers in there, you'll see, because it could, remember that distribution we were talking about, my box plot can still be skewed left or skewed right, or even symmetric. So it could, if I've got lots of outliers, it's going to pull those numbers on the low end, it's going to pull the numbers down. If I've got lots of outliers on the high end, it's going to pull those numbers up. So you're right. And I think it'll make more sense once I put some numbers in there for you. You okay?
Yeah, I think I'm sure that MINITAB will help me.
Let me work it with the numbers, and then if you still have a question, I'll see if I can re-explain it for you. Okay. All right. I think last time we were looking at age. And so I'm going to do age. So we have our data set pulled into MINITAB. We want to calculate the descriptive statistics. So they are statistics. So across the top at my menu bar, I'm going to go to stat. I'm doing basic statistics, and I want to display the descriptive statistics. The variable I'm using is age. So I'm going to double click on C6. And then I use the little widget here that says statistics to select all of the things that I wanted. Okay, we wanted the mean, standard deviation, variance, first quartile, median, third quartile, interquartile range, the mode, oh, that's the two that I forgot. Minimum, maximum, guys. I left that off your list. I'll go back and put it. I'm sorry. I thought I had missed a couple and I did. I'll go back and put that on your list in just a minute. Okay, so we tell MINITAB all the things that we want: mean, standard deviation, variance, first quartile, median, third quartile, interquartile range, mode. We want the minimum and the maximum, the range. Then we want in non-missing, in missing, and in total. Let me go back right now before I forget. I thought I had missed a couple and I did. Okay, we also want minimum, maximum. Okay, once you get all of those options selected, we click OK. We click OK again, and MINITAB gives us those results here in the top of the screen. Now I want to copy these over to my paper. Now what you'll be doing is you'll be doing the questions on the computer, so you may want to write these down and be where you can look at them, because basically what you're going to do is you're going to identify, and I think it's matching. So like if I'm looking for the mean, I can look at my output here and see that my mean, if you guys can see it, the mean was 29.699. Okay, so I would simply write that down. Okay, we would write my mean is 29.699. Then, you just read the numbers off. The median was 28. You're just looking at the output, and you will match up the different values. Okay. The mode, I want to show you about the mode. The mode was 24, and MINITAB tells us that that value occurred 30 times, meaning there were 30 people on the Titanic, or that we know about, that were 24 years old. So my mode was 24. The range is 79.580. Variance is 211.019. Guys, MINITAB has done all the work for you. The variance was 14.526. The minimum, there was one that was 0.42, so you had an infant, most likely, because they're not even a year old. The maximum, you had an individual who was 80. Q1 was 20. Q3 is 38. IQR would be 18. We had a total of 891. 714 were given to us. We had 177 missing. Okay, so MINITAB gives you all of those numbers. Now, I'm not going to ask you to draw the box plot by hand, but I want to try to help with your understanding. I want to try to show it to you visually here. Okay, so if I were going to take this data and create a box plot by hand, okay, it may be hard to get it all on here. Okay, I would have my minimum, which is, I'm going to say roughly, I'm going to start at 0 on my scale, and I got to run my scale all the way up to the maximum of 80. So I'm going to kind of maybe count by tens: 10, 20, 30, 40, 50, 60, 70, 80. Okay, so if you want to kind of, you usually have kind of this number line or a scale. Okay, so here's my number line. And then I'm going to put my points on there. My minimum would be 0.42, so it would be somewhere right here. This is the minimum, and I'm going to put 0.42. My maximum would be on the other extreme, which is 80. My max is 80. Let's see, Q1 is 20. So Q1 would be here. Q3 was 38, so I have to kind of estimate. Q3 is 38. And I need my median. The median was 28. So my median's going to be probably somewhere right in here. And again, normally for the box plot, you would see a box drawn around Q1 to Q3. Usually there's a bar at the median, and we run the whiskers, if you will, out. Now, let's think for just a minute. Remember last class, and I'll go back and recreate it real quick. We looked at the histogram for the ages. Do you remember what we said in terms of with this histogram? We talked about the distribution. Do you remember if we saw what we said? Do we think it was symmetric, skewed left, skewed right? Do you remember? If not, look at it again. What do you think? With this histogram, would our data set be skewed left, skewed right, or symmetric? Somebody put it in the chat. Okay, Joey thinks it's skewed right. Okay, so if he's saying skewed right, that means we think we have more data values kind of on the low end than we do the high end. And then remember, at this point, we're using our eyeballs and our gut. So our eyeballs and our gut are saying it's skewed right. I can play the devil's advocate and say, well, I think it's symmetric. Because look at this, my hand-drawn box plot. Now, granted, it's not perfect, okay? But look at the box plot. Look at where the box is located. Is the box more to the low end, more to the high end, or in the center. That's how you tell the difference. If it's on the low end, we would say skewed to the right. If it's on the high end, it's skewed to the left. And if it's in the middle, it's symmetric. To me, when I look at this box plot, even my hand drawn one, oh, somebody thought it was symmetric. And I don't disagree with you. Again, if you're using your eyeballs, it's okay if we disagree because different people may see it differently. But to me, when I look at this box plot, it looks a little bit more skewed to the right. Okay, again, I want to kind of try to help answer Jeannie's question. So let's think about the outliers. If I were going to try to determine without knowing whether or not we have outliers, I would do the hand calculation. I'm going to calculate Q1 minus 1.5 times the IQR. Okay, so Q1 was 20 minus 1.5 times the IQR, which was 18. And guys, you can use your handheld calculator to do that. So I would do 20 minus 1.5 times 18, which equals, whoops, you can't see it, -7. Okay, so if I'm trying to look at it on this graph, -7, if I'm looking about where my outlier might be, -7 is actually going to be off the chart. Okay, I'd have -7 way over here. Well, think about it. I don't have anybody that's younger than 0, so I don't have any outliers on that low end. Okay, I don't have any outliers on that low end because, I mean, it doesn't make sense to have somebody that's a negative age. The lowest they could be is 0. And that might mean they were in utero. Okay, then on the other side, we would have Q3 plus 1.5 times IQR. Okay, so we would have Q3 is 38 plus 1.5 times IQR, which is 18. Again, use your calculator. I don't expect you to do it in your head. 38 plus 1.5 times 18. Okay. And I see the chat. 65. Very good, Joey. Okay, is 65. Whoops. So my cutoff for the outliers is 65. Well, I know that I had at least one person that was 80. So see, if I run this number out to 65, there's my cutoff. That means from a visual perspective, any person that was over the age of 65 up to that oldest of 80 was an outlier. So any passenger on the Titanic that was older than 65 is an outlier. Jeannie, does that make a little bit more sense now that you can kind of see the numbers? I see a thumbs up.
Yeah, so I was trying to like drop those out. I was thinking we drop those outliers and how do we, but we calculate them. That makes sense.
Well, we are calculating them and we're going to leave them in the data set. Now, again, in real world research, sometimes if you can justify it, there are techniques for eliminating those outliers, but we're not going to get into that much detail. Let me also show you, though, this is how you do it by hand. So we would say any person over the age of 65 was an outlier. But you can also get a visual of that by using a box plot. Remember, that was one of the other graphs that I asked you to be able to create. And so we can do that in MINITAB. It is a graph. We want a box plot. So if we scroll the list, I find a box plot. Again, we keep it simple. gotta get to my okay. Well, I gotta get to my okay box. Let me see if I can move it up. Graph, box plot, keep it simple. There's my okay. Again, we choose age. We can look at options. It has us, I want it to draw the interquartile range box, and I want it to show me the outliers. The box plot in MINITAB will actually give you a visual of the outliers, and I'll show you that. Okay, and then we click OK. And I'm going to copy this over. Again, I can change. Remember, we talked about changing the title. I would change it to maybe Titanic passengers ages. And we were indicating that those ages were in years. So we talked about how to do that last class. We select it, use the arrow, and we copy. I want to get it where you can see it. Now, one of the differences between the one I drew by hand and the one that you'll see here is MINITAB draws it on a vertical. See, they have the scale, they have the age, 0, 10, 20, 30, 40. They go up to 90. Okay, we had to go to 80 because that was the maximum. Okay, again, this comes out. That's probably your minimum. This first line is Q1. The middle line is the median. This line is Q3. This is kind of your outlier cutoff. It's not really your maximum because it keeps going. I see those little stars. This is your outlier cutoff. That occurs at 65, and I can show you that in just a second. Okay, see all these little stars? Some of them are bunched here close together around the 70 mark. All those little stars are outliers. That's how MINITAB on the box plot represents outliers. All of these little stars are outliers. So I get a visual from my box plot. I want to show you something too, though. The box plot, again, even if you haven't calculated those descriptive statistics, you can actually if you hover your mouse, for example, over this rectangle, notice it gives you the information. It tells me that Q1 is 20, the median is 28, Q3 is 38. It gives me the IQR, which is 18, and it tells me that those whiskers go to 0.42, which would be my minimum, and the other one goes to 65, which we calculated to be that upper outlier number. And if I hover over the stars, it'll tell me that that's an outlier symbol, that it's age 80, and it's on row 631 of my data set. This one, the person was 66, and that's on row 34. This person was 74. Okay, so if you're in MINITAB, now it doesn't work if I use the copied one. Okay, notice it doesn't give me that on the copied one. But if you're in MINITAB and you hover your mouse over those pieces, it's going to give you that information. Yes, Jeannie, 80 is our maximum, is the maximum value in this data set, but it is actually an outlier. Okay, other questions that you may have, and I got one more thing that I need to show you. We were kind of debating whether the graph of the histogram or even the graph of the box plot was skewed left, skewed right, or symmetric. There is a way to determine without a doubt, whether it is skewed left, skewed right, or symmetric. And that goes back to this distribution that we talked about earlier, and I want to give you that information. When you're looking at it with your eyeballs, it is open to interpretation. Even, you know, to me, when I first saw that histogram, I felt like it was symmetric. But then when I looked at the box plot, it kind of looked skewed right. So, you know, even I disagreed with myself. And so we need a way to kind of verify, confirm, prove, if you will, which one it is. And the way we do that is we look at the relationship between the measures of center. Okay, so we're going to look at the relationship between the mean, the median, and the mode. Now I'm going to add a little caveat to that. We did talk about how the mode could have more than one value, could be more than one value. And so sometimes the mode kind of misbehaves, if you will. And so if it does, we just don't include it because it's not really a calculation. We're just looking for the one that occurs the most. So if you're looking at the distributions, whether you're looking at the histogram or the box plot, and you're kind of like, well, I really am not sure, look at the mean, the median, and the mode. If the distribution is skewed to the left, you will have the mean will be your smallest value. Then you'll have the median and then the mode. They kind of rank in that order. The mean is less than the median, which is less than the mode, if the distribution is skewed to the left. If it is symmetric, the mean, the median, and the mode are all virtually the same value. If it is skewed to the right, the mode will be the smallest, then the median, then the mean. Okay, mode is less than the median, is less than the mean. So let's go back and look. We think we've had a, you know, kind of a disagreement, but we think that our histogram is either skewed right or it is symmetric. So I want to look at the mode, which was 24. What was our median? I had it on my box plot. The median was 28. And the mean, I believe, was 29.699. Okay, so if we look at the comparison of those three numbers, the mode, which is 24, is less than the median, which is 28. And 28 is less than the mean, which is 29.6. So based on the numbers, the mode is less than the median, which is less than the mean, which verifies that the distribution is skewed right. And guys, it's skewed right if it's a histogram, it's skewed right if it's a box plot. The graph doesn't matter because the data doesn't change. Based on the numbers, the data itself is skewed to the right. So my first gut instinct of it being symmetric has been disproven or was inaccurate, because once I see those numbers, 24, 28, and 29.699, those are not almost the same value, but they follow the guideline for being skewed right. Okay, so we initially used kind of our eyeballs and our gut, and everybody kind of had a different opinion, but we can verify or prove it by looking at the measures of center and their relationship. Questions? Just to finish the PowerPoint, there are different ways for presenting the data. We can use tables, we can use graphs. It kind of depends on who the audience is, how quickly you want to communicate the information. Using graphs or tables is probably the quickest way. And I just have on the last couple of slides of this PowerPoint some different ways that you'll see information presented. Again, it can be in a table form, in a variety of ways. There's no necessarily set rule or guideline for how to present the data. You can also do it graphically. And again, if you're doing it with quantitative data, primarily you're going to probably see a histogram or a box plot. Now, again, there are other graphs, but those are the two that are used most often within the world of research. Okay, that finishes our discussion of missing data, descriptive statistics, and outliers, which was the second lesson in Module 1. You should now be able to complete Quiz 2, but you will need access to MINITAB. So is anybody having difficulty accessing MINITAB? Jeannie, did your access come back?
Yeah, I was able to get in today.
Okay, good deal. Okay, if you haven't tried to download it, if you have the opportunity between now and 2 o'clock to do so, give it a shot. If you're having trouble, remember I run office hours in Zoom from 2 o'clock to 4 o'clock this afternoon, and I can try to walk you through it individually if you're having difficulty. But you will need MINITAB to access or to complete Quiz 2. Quiz 2 is due by Sunday. I also would encourage you to begin working on Mini Project 1. Okay, again, to remind you where to locate that, if you go to the course homepage, under Module 1, in that folder, you'll find Mini Project 1. You select a data set. Again, if you want something perhaps related to your particular field of study, I've tried to provide a variety there. A lot of students enjoy the US president's physical data. It's just kind of a fun data set. So a lot of students tend to enjoy that. And so you choose the data set that you want to use. You will use the same data set for all of the projects throughout the semester. Okay, you'll use one for the same one for all of the projects throughout the semester. The instructions are at the bottom. Okay, you can click on the instructions and it will open them up. And I had them open earlier, I thought, but maybe I closed them. Okay, so again, you select your data set. You choose the qualitative variable you're going to use for this assignment, and you choose the quantitative variable, because you have to clearly identify the data set and the variable that you're using. Otherwise, I don't know which thing to use when I grade your paper. Okay, so please clearly identify the data set and clearly identify the variables. You have to create a bar graph and then kind of summarize it. I give you some idea about the type questions you want to answer. I'd love to see that in a paragraph form like you would write if you were writing it for a report, you know, not just simple sentences answering the question. Kind of write a nice, you know, paragraph that summarizes what you've learned. I do try to provide you with some examples from the internet on qualitative. We've also talked a little bit about that in class. Then you also have to do quantitative. You have to do a histogram and again do a summary of that. Then using the same variable, don't change variables, you also do a box plot. Interpret the box plot. Again, writing that nice little summary. Please be sure to interpret each quartile. 25% of the data fall below whatever quartile 1 is. 50% of the data fall below the median. Okay, I showed you how to do that earlier. Then you calculate your descriptive statistics, primarily your 5-number summary, the mean and the standard deviation. You verify your outliers, then talk about the distribution. Is it skewed left, skewed right, or symmetric? And you verify that by comparing the mean, the median, and the mode. Okay, again, I'd love to see it kind of more in a paragraph type form. If you just go through and answer the questions, that'll get the job done. But again, in the real world, guys, think about how you would write this if you were going to have to share your results with your employer. Okay, you would probably write up a report more so in paragraph form, because I want you to kind of have that experience of what you might expect in the real world. And guys, y'all forgot to tell me I was not sharing the screen again. I forget sometimes. You got to tell me. Speak up. Don't be shy. Okay, questions. I got 3 minutes left. Do you have questions? But if you can, start working on mini project 1 so that next week, if you have questions, I can try to answer those for you before you have to submit it.
I just had a question concerning last week. We had you had went over what we needed to download to our computers, but I tried that last night and then it was telling me I have to like download an app to my laptop, which I don't even have the app. I don't know, it was just a lot of confusion. So my question is like, is it required that we download it or could we just plug in the information?
Are you talking about MINITAB?
Yes.
Okay.
Like the quiz 2, that the link, I think it was, that we had.
For quiz 2, Catrice, you are going to have to either in Excel format, but I think here's your confusion, I think. Okay, let me remind you. Okay, where you do you have the access to MINITAB?
Yes, ma'am. I do now.
So you can get MINITAB access on your device.
Yes.
Okay. Are you using the device on which you have MINITAB to access quiz 2?
Yes.
Okay. All right. Let me see if I can get this to come up. It's thinking about it really hard. Okay. You're going to, if you go to where that data is located under the descriptive statistics, missing data, and outliers file, if you're pulling it down in the MINITAB format, remember I mentioned, and I was going to try to do it, but it's giving me fits here. When you pull down that file, you don't try to open it on your desktop. Okay. Remember, when I do this MINITAB file, if I'm using this MINITAB format, I think you can see my screen.
Yes.
I'm going to click on it and I'm going to save it like on my desktop, but I'm just going to save it. I am not going to try to open it. See, it gives me this error.
Yes, we will study next.
It's okay. I'm not going to worry about the error. So I don't want to open it on that PC. I'm going to go out to MINITAB, and I'll have to get MINITAB pulled back up again. app.minitab.com. Okay. And then I'm going to pull that file in. I didn't try to open it. It gave me an error. I know there's going to be an error. I'm going to go out to MINITAB and go to File. I want to open a project from a local file. and then I find the hospital data file that I just pulled out of the lesson. I'm going to click on it. And because now I'm in MINITAB, see that file has a suffix of .mpx. M, that's the designation for MINITAB. P tells me that it's a project, and then you got the X. I don't know what the X stands for. Okay, so I pulled it into MINITAB and it opens. But I agree with you, it's not going to open if you try to open it on your desktop. It's going to give you that error. Okay, but if I save it on my desktop, okay, it gives me the error. I do not care. Just ignore the error. Go out to MINITAB and pull it in.
Okay, I got that.
Okay. I walked through that a couple of times on the video at the beginning. I think it was the beginning of the video from Tuesday. So you might want to go back because I went through it pretty fast here. You may want to go back and look at that one. But I think that may be the issue that you're having. You're trying to open it and but it's giving you that error.
Yes,
and
ma'am.
it will, but then if you go into MINITAB, it's going to open up for you.
Okay, thank you.
You're welcome. Okay, it's 12:17, so I know we're a little bit over, but do you have other questions? All right, guys, I'll see you Tuesday then.